You think you understand color. You look at a red apple and you know it's red. You see the blue sky and you know it's blue. You've learned that objects have colors, that light reflects off them, but your eyes detect the colors and send signals to your brain. Simple, obvious. The apple is red because it's red. Wrong. Stop right there. Here's a question that should make you uncomfortable. What is red? Don't tell me it's a wavelength. Don't tell me it's light at 650 nanometers. I'm asking what red is. What is the redness you experience when you look at that apple? Where does that sensation exist? Is it in the light? Is it in the apple? Is it in your eye? Is it in your brain? Think carefully. The light bouncing off the apple has no color. It's an electromagnetic wave oscillating at a certain frequency. Electromagnetic waves don't have color, any more than sound waves have color. They're just energy propagating through space. The apple itself is made of atoms, of electron clouds and nuclei, of quantum field configurations that we just talked about. Those quantum fields don't have color either. Color isn't a property of matter. So where is the red? You're starting to feel it, aren't you? That queasy sensation that your understanding is built on circular reasoning. The apple looks red because it reflects red light. And red light is red because it makes things look red. And things look red because... Stop. You don't know. Here's another question. Is the red you see the same as the red I see? You want to say yes. We both point at the apple and agree it's red. We've been trained since childhood to use the same word. But the subjective experience of redness, the quali, the raw sensation, how do you know that's the same? You can't get inside my head. You can't compare your red to my red. For all you know, your red looks like my blue, and we'd never discover the difference because we learned to call the same objects by the same color names. This isn't philosophy. This is neuroscience meeting physics meeting the hard problem of consciousness. And the answer is going to dismantle everything you thought you understood about the world you see. Let me start with what you think you know. Light comes in different wavelengths. Visible light ranges from about 380 nanometers to 750 nanometers. Shorter wavelengths are violet, longer wavelengths are red, and the middle is green. When white light hits an object, the object absorbs some wavelengths and reflects others. A red apple absorbs most wavelengths and reflects wavelengths around 650 nanometers. Those reflected wavelengths enter your eye, hit your retina, and you see red. This explanation feels complete. It's causal. It's physical. It explains the mechanism. It explains nothing. Here's why. Your retina doesn't have red detectors. It doesn't have blue detectors. It doesn't have green detectors. Your retina has 3 types of cone cells, and each type responds to a broad range of wavelengths. The so-called red cones actually peak their response around 564 nanometers, which is yellow-green. The green cones peak around 534 nanometers. The blue cones peak around 420 nanometers, and their response curves overlap massively. When light at 650 nanometers hits your retina, it doesn't trigger just the long wavelength cones. It triggers the long wavelength cones strongly, the medium wavelength cones weakly, and the short wavelength cones barely at all. Your brain receives 3 numbers, the relative activation of L, meters, and S cones. That's it, 3 numbers. And from those 3 numbers, your brain constructs the entire rainbow of color you perceive. Not just red, green, and blue, not just the spectral colors, but orange and yellow and cyan and magenta and brown and pink and all the colors that don't even exist in the rainbow. Colors that aren't wavelengths. Colors that are invented by your visual system. You've been lied to. The color wheel you learned in school is fiction. Red, yellow, and blue are not primary colors. Red, green, and blue are not the colors of light. Your perception of color has almost nothing to do with the actual physics of light and everything to do with the computational neuroscience happening in your visual cortex. Let me prove it. Magenta doesn't exist. No, seriously. There is no wavelength of light that corresponds to magenta. Look at the spectrum of visible light. It goes from violet to blue, to cyan, to green, to yellow, to red. There's no magenta in that sequence. Magenta is what your brain invents when both your long wavelength cones and your short wavelength cones are activated strongly, but your medium wavelength cones aren't. It's your brain's way of completing the circle, of connecting the 2 ends of the visible spectrum. Magenta is a hallucination, a useful, consistent, reproducible hallucination that everyone with typical color vision experiences the same way. but a hallucination nonetheless. It's not in the physics, it's in your head. And it's not just magenta. Brown doesn't exist as a wavelength either. Brown is what your brain calls orange when it's surrounded by brighter colors. Show someone an orange light in isolation and they'll call it orange. Surround it with brighter white light and suddenly it's brown. Same wavelength, different perception. The brownness exists only in the context created by your visual system. Pink is the same deal. Pink is desaturated red. Red mixed with white light. But white is also invented by your brain. White light isn't a wavelength. It's a roughly equal mixture of all visible wavelengths. And your brain interprets that mixture as colorless, as the neutral point, as white. In a very real sense, white is the absence of color, even though it's the presence of all wavelengths. You're starting to see it now, aren't you? Color isn't in the world. Color is a construct your brain creates to encode information about the spectral composition of light. It's a user interface. Your brain is taking physical data, 3 numbers from 3 types of photoreceptors, and transforming it into a subjective experience that has no direct physical correlate. The redness of red doesn't exist in the 650 nanometer electromagnetic wave. It doesn't exist in the photons bouncing off the apple. It exists in your brain as a computational solution to the problem of representing spectral information in a useful way. Your brain could have chosen any arbitrary sensation to represent that pattern of cone activation. The fact that you experience it as red is contingent, not necessary. It's a mapping from physics to qualia that evolution settled on because it worked. Now push deeper. Ask the next question. Why 3 types of cones? Why not 2? Why not 4? Most mammals have 2 types of cones. Dogs, cats, horses, they're dichromats. They see the world in 2-dimensional color space instead of 3-dimensional. They can't distinguish red from green the way you can. Their color palette is impoverished compared to yours. Not because the wavelengths don't exist, but because they can't construct as rich a perceptual space from only 2 data points. Some humans are dichromats too. Color blindness isn't blindness to color. It's having only 2 cone types instead of 3, or having cone types with abnormal spectral sensitivities. The most common form is red-green color blindness, where the L and meters cones have very similar response curves. These people literally cannot see the difference between certain reds and greens because their visual system doesn't have enough independent channels to distinguish them. The wavelengths are different, the physics is the same, but the subjective experience is collapsed. On the other hand, some birds have 4 types of cones. They're tetrachromats. They see in 4-dimensional color space. They can distinguish colors that look identical to you. Imagine trying to explain to a bird what it's like to see in only 3 dimensions of color. You can't. You literally cannot perceive what they perceive because you don't have the neural machinery to construct that perceptual dimension. And here's the disturbing part. Some human women are tetrachromats. Due to X chromosome genetics, some women have 4 distinct types of cones instead of 3. They see colors the rest of us cannot distinguish. They live in a richer color space. When they look at what you call a solid green, they might see subtle variations you cannot perceive. Their red is not your red, not because of subjective differences in qualia, but because they have access to an entire dimension of color space you lack. Color is not universal. It's species specific. It's even individual specific. The color space you inhabit is determined by the photoreceptors you happen to be born with, the neural wiring that happened to develop in your visual cortex, the computational algorithms your brain uses to process cone signals. Another human with different genetics sees a different palette. Another species with different photoreceptors sees a profoundly different world. And none of them are seeing what's really there. Because what's really there is electromagnetic radiation at various frequencies. And electromagnetic radiation doesn't have color. Color is the representation your nervous system uses. It's not the territory. It's a map. But here's where it gets truly strange. Your brain doesn't just create color from cone signals. It invents it. It fills it in. It makes it up where no information exists. Look at something with one eye closed. Now look at your blind spot, the place where your optic nerve exits your retina, where you have no photoreceptors. You can find it by holding your thumb at arm's length, closing one eye, and moving your thumb until it disappears. When your thumb is in your blind spot, you don't see a black hole. You don't see nothing. You see a continuous field of whatever surrounds it, Your brain invents the color and texture that should be there based on context. This isn't filling in missing data with a good guess. This is fabricating sensory experience. Your brain is generating color qualia for a region of space where no light is being detected. The color you see in your blind spot is pure confirmation, and you'd never know unless someone told you. Your brain does this constantly. Your retina is moving in tiny saccades multiple times per second. Your photoreceptors are constantly adapting to ambient light levels. You blink, disrupting the visual signal entirely, and yet you experience a stable, continuous, colored world. Your brain is smoothing over the gaps, predicting what should be there, maintaining the illusion of continuous perception, even though your sensory input is fragmented and unreliable. The world you see is not the world it is. It's a simulation your brain constructs from limited, noisy data. Color is part of that simulation, and sometimes the simulation breaks in revealing ways. The dress. You remember the dress, the photograph that broke the internet because people couldn't agree whether it was blue and black or white and gold. Same photograph, same wavelengths of light coming from your screen, different perceptions. How is that possible? Because your brain doesn't just measure the wavelengths hitting your retina. It interprets them in context. It tries to figure out what the illumination is, what the object's actual reflectance properties are, whether the scene is in sunlight or shadow. This is called color constancy. A white piece of paper looks white in sunlight and white under tungsten lighting, even though the wavelengths reflected are completely different. Your brain compensates for the illumination to extract the intrinsic property of the object. The dress photograph was ambiguous. It could be interpreted as a blue and black dress in bright light or a white and gold dress in shadow. Different people's visual systems made different assumptions about the illumination, and those assumptions led to radically different color perceptions. Same input, different computations, different qualia. Your perception of color is that fragile, that dependent on context and interpretation. Here's another example. Stare at a red screen for 30 seconds, then look at a white wall. You'll see a cyan afterimage. Why? Because your long wavelength cones adapted to the constant red stimulation became less sensitive. And now when you look at white light, which should activate all three cone types equally, your L cones are temporarily weakened. The ratio of cone activations is skewed toward meters in S, and your brain interprets that as cyan. The cyan you see is not in the raw. The raw is reflecting white light. The cyan exists purely in your adapted visual system. It's a computational artifact, and yet it's as vivid and real as any color you perceive. You cannot tell the difference between cyan that comes from the world and cyan that comes from your neural adaptation. Both are equally constructed. Both are equally qualia. This is the truth you need to absorb. Color is not a property of objects. It's not even a property of light. It's a property of perception. It's a way your brain encodes information about spectral reflectance and illumination, a user interface that evolution built because it was useful for survival. The color space you inhabit is no more fundamental than the desktop icons on your computer screen. It's a representation, and like all representations, it abstracts away the underlying reality in favor of useful simplifications. The underlying reality is quantum electrodynamics. When light interacts with matter, photons are absorbed and emitted by electrons transitioning between energy levels. The specific wavelengths absorbed depend on the electronic structure of the atoms and molecules in the object. A red pigment molecule absorbs photons in the blue and green part of the spectrum because those photon energies match the energy gaps between its electronic states. It reflects red photons because their energy doesn't match any available transition. This is pure quantum mechanics. Energy level diagrams, selection rules, Fermi's golden rule, calculating transition probabilities. At the fundamental level, there's no color. There's electromagnetic waves with specific frequencies determined by the quantum mechanical properties of electrons and photons. The frequency of a photon is directly related to its energy by Planck's constant. E equals h times frequency. A red photon at 650 nanometers has an energy of about 1.9 electron volts. A blue photon at 450 nanometers has about 2.8 electron volts. That's it. That's the only difference. Energy, frequency, wavelength. all interrelated by fundamental constants. Your cone cells contain opsin proteins that change shape when they absorb photons. The shape change triggers a cascade of molecular signals that eventually generate an electrical signal in your retinoganglion cells. The ganglion cells compare signals from different cone types and send the differences to your brain. Your primary visual cortex processes these signals. Your V4 region, along with regions in the inferior temporal cortex, construct the perception of color. Neurons that respond preferentially to certain color combinations. Neural populations encoding color in an opponent process framework. Red versus green, blue versus yellow, light versus dark. This is all neuroscience. This is all biophysics. This is mechanisms and signals and neural computations. And nowhere in that causal chain is there an explanation for why it feels like something to see red, why the subjective experience of redness exists, why qualia are what they are. This is the hard problem of consciousness in its purest form. You can trace the entire causal chain from photon absorption to neural firing to behavioral response, and you've explained the function of color vision. You've explained how organisms can use spectral information to identify ripe fruit, avoid predators, find mates. You've explained the what and the how, but you haven't explained the why of subjective experience. Why does the neural processing of opponent color signals feel like red? Could it have felt like anything else? Could the same neural processing have produced a completely different quality? These questions may not have answers. They may be the wrong questions. Asking why redness feels red is like asking why electrons have the charge they have. At some point you hit bedrock. Subjective experience might be fundamental, might be what certain patterns of neural activity feel like from the inside, and there might be no deeper explanation. The redness of red might be what it's like to be a visual cortex processing a certain pattern of signals, and that might be as far as explanation can go. But even if we can't explain qualia, we can recognize them for what they are, internal representations that have no necessary connection to external reality. The redness you experience is not in the electromagnetic wave. It's not in the photon. It's not in the atoms of the apple. It's in you. It's a phenomenal property of your conscious experience, generated by neural computation, useful for behavior, but not reflecting any intrinsic property of the physical world. Every color you've ever seen, the blue of the sky, the green of grass, the yellow of sunlight, the infinite gradations and combinations, all of it exists only in nervous systems, only in brains that have evolved photoreceptors and neural processing streams to extract spectral information from light. If every conscious being disappeared from the universe, wavelengths would still exist. Electromagnetic radiation would still propagate, but color would vanish. Not because the physics changed, because color was never in the physics to begin with. You are a biological organism that has evolved to navigate a world of reflected light, and your nervous system has built a perceptual interface to represent spectral information. That interface is color. It's adaptive. It's useful. It's beautiful, but it's not reality. It's a translation of reality into a form your brain can work with. The map is not the territory. The color is not the wavelength. The quale is not the photon. Look at your hand. You see skin tone, maybe pink or brown or somewhere in between. That's your brain interpreting the spectral reflectance of melanin and hemoglobin in your skin. The actual physics is electromagnetic radiation between 400 and 700 nanometers being absorbed and reflected by molecules with specific electronic structures determined by quantum mechanical energy levels. Your brain takes that information and paints it flesh color. The flesh color exists in your perception. The electromagnetic radiation exists in the world. They are not the same thing. Look at a sunset. You see oranges and reds and purples. That's your brain interpreting the fact that sunlight is passing through more atmosphere at a low angle. Rayleigh scattering is preferentially removing shorter wavelengths, and the remaining long wavelength light dominates. The blue light isn't gone. It's scattered into the rest of the sky, which is why the sky is blue when the sun is high. Same physics. Your brain paints the direct sunlight orange, paints the scattered light blue, and you experience a colored world. The colors are in your head. The electromagnetic phenomena are in the atmosphere. You live in a world of color that doesn't exist. You experience richness and variation and beauty that is entirely constructed by your neural hardware. The physical world is colorless vibrations of electromagnetic fields at different frequencies, and your brain has transformed that abstract oscillation into the concrete experience of color. Not because color is there to be detected, but because representing spectral information as color was evolutionarily advantageous. Your ancestors who could quickly identify ripe fruit based on color outcompeted those who couldn't. Your color vision exists because it helped you survive, not because it reveals truth. But here's the magnificent part. It works. Your invented, constructed, hallucinated color experience allows you to navigate the world effectively. You can identify objects. You can detect patterns. You can communicate about shared experiences, even though your qualia might be different from mine. The interface is reliable. The representation is consistent. The simulation is stable enough that you can build a civilization on it. This is what physics and neuroscience together reveal. The world you perceive is not the world that exists. What exists is quantum fields, electromagnetic radiation, atoms and molecules interacting through fundamental forces. What you perceive is a user interface built by evolution, tuned by development, running on neural hardware. Color is part of that interface. It's a brilliant solution to the problem of representing spectral information in a compact, usable, conscious form. The redness of red is not out there in the world. It's in here, in your subjective experience, generated by neural computation, mapped from physics, but not identical to physics. Color is what it feels like from the inside when your visual cortex processes certain patterns of cone signals. It's phenomenology emerging from mechanism. It's consciousness doing what consciousness does, creating a felt experience of the world that is useful for action, even if it's not isomorphic to reality. You wanted to know what makes colors exist. Now you know. Colors exist in nervous systems. They're computational constructs. They're phenomenal properties of conscious experience. They're maps, not territories. They're representations, not things in themselves. The truth hasn't just refracted everything you think you know. It's dissolved the very distinction between color and perception, between property and experience, between world and mind. Color is the interface. You are the user. The physics is running underneath, indifferent to your experience of it. And the color you see, vivid, immediate, undeniable, exists nowhere but in the subjective space of your consciousness. This isn't disappointing. This is extraordinary. Your brain takes 3 numbers from 3 types of photoreceptors and constructs an entire perceptual dimension. It invents magenta and brown and pink. It maintains color constancy across wildly different illuminations. It fills in your blind spot. It adapts and adjusts and computes and renders a stable colored world from fragmentary, noisy, ambiguous data. The fact that color is constructed doesn't make it less real. It makes it more impressive. You are a pattern of neural activity experiencing itself as a colored world. The colors aren't illusions. They're the reality of your subjective experience. But they're your reality, not the universe's reality. The universe has wavelengths. You have red. Those are 2 different things, connected by the remarkable machinery of perception, but forever separated by the explanatory gap between physics and phenomenology. Stop thinking of color as a property of objects. Start thinking of it as a property of experience. The red is not in the apple. The red is in you, constructed by your visual system, shaped by evolution, instantiated in neural firing patterns, and experienced as the subjective quality we call redness. That's what color is. That's what color has always been. And once you see it, you can never unsee it. The world is not colored. You are.